Let's recall how we found the derivative of sine and cosine functions. So derivative of sine function is this limit. Derivative of any function is this limit. H approaches 0 and you evaluate the function at x plus h. So it would be sine of x plus h and you subtract f of x. So in this case, you subtract sine x and you divide by h. And then we use the difference of signs formula and we used a special limit. And we found that it simplifies to cosine x. And so this limit evaluates to cosine x. And now we want to remember this because we don't want to use the definition every single time. If we are asked to find the derivative using the definition, we have to, but a lot of times, if you can just remember, that would be helpful. And also, we found the derivative of cosine x to be, so we wrote something like that, and then we used the difference of cosines. And this turned out to be negative sine x. And after we do that, we want to remember sine's derivative is cosine, cosine's derivative is sine. So now notice, if I were to take the integral of sine, then I'm looking at this equation. From cosine, I get negative sine. So if I were to integrate negative sine, I would get cosine. But negative is a constant that can be taken out of the integral. So if you integrate just the sine x, you would get negative cosine x plus c. And to integrate cosine x, you say, if you differentiate sine x, you are getting cosine x. So cosine x is coming from sine x, which means integral of cosine x will be positive sine x. So these are the derivatives of, the integrals of sine and cosine x. They are pretty straightforward. If you remember the derivatives of sine and cosine, then you also know the integral of sine and cosine. Now, in next videos, we'll talk about the integral of the other trig functions. They are a little bit more complicated. The integral of tan x, cosecant x, secant x, and cotangent x. And